then followed by opening remark by the Dean of Faculty of Agriculture, Udayana University, as well as opening the joint lecture. Then followed by opening remark by the Dean of Faculty of Science, University Malaya, Malaysia. Then followed by presentation by invited speakers, followed by discussion, and end with shared conclusion. And the end is closing, awarding of certificates to speakers and moderators, and also a group photograph. For the next agenda, we invite the Dean of Faculty of Agriculture, Professor Dr. Insinyur I. Nyoman Gede Ustriana, MM, to give a speech as well as to open the joint lecture. The Professor, time is yours.
You. Om Swastiastu. Assalamualaikum warahmatullahi wabarakatuh. Salam, salam sejahtera untuk kita semua. Namo Buddhaya. The Honorable Dean of Faculty of Science, University Malaysia, Professor Dr. Zulkarnain Mohammed, or his representative, the Honorable Vice Dean of Faculty of Agriculture, Udayana University, the Honorable Invited Speaker, Associate Prof. Dr. Nur Kartini Abu Bakar from Faculty of Science, University Malaya, Malaysia, and Professor Dr. Insinyur Nyoman Rai MS, Faculty of Agriculture, Udayana University. The Honorable Professor and Lecturer, invitees and participants, both from Udayana University and University of Malaya. Postgraduate and undergraduate students from both universities, Udayana University and University Malaya. And last but not least, the entire committee who have worked hard to organize the event. Rise with God as we are blessed with God's health and prosperity due to His grace. Today marks a moment of occasion as the Master Program of Agriculture Technology, Faculty of Agriculture, Udayana University, in collaboration with the Department of Chemistry, Faculty of Science, University Malaya, present the joint lecture on chemical pollution and its impact to environment. Ladies and gentlemen, it's important to highlight that this collaboration between these esteemed institutions constitutes the fulfillment of the Memorandum of Understanding signed in December 2018 and set to conclude in December 2023. We intend to extend the MOU and we are grateful for the foresight of both parties head, namely Professor Dr. Rindang Duyani and Associate Professor Dr. Nur Kartini Abu Bakar in initiating the relations of this meaningful collaboration through today's joint lecture. We are honored to announce our collaboration with the University of Malaya, a world-renowned institute that is currently ranked 17th globally. As the Faculty of Agriculture at Udayana University, we aim to strengthen our partnership with this esteemed university by furthering our cooperative effort in research and other that fall under the three dharma of higher education. Today's lecture will focus on the critical topic of chemical pollution. Leftover chemical and waste from various experiments can be extremely harmful, both of human health and the environment. Therefore, it is crucial that we dispose of chemical waste responsibly. This issue affects everyone as we all have a potential to be exposed to this hazard material. Ladies and gentlemen, environment exceeds chemical waste that can result in several diseases, disabilities, and even death. Lead, for example, can lead to nerve of digestive disorder as well as heart damage. In children, high level of lead can lower intelligence score and increase the likelihood of mental disabilities. Meanwhile, exposure to high level of chromium can lead to the development of lung cancer. One way we can minimize the hazard by learning comprehensive waste management techniques that allow us to control and contain chemical waste. Experience alone cannot be adequately equipped as we this understanding, but we can gain knowledge by pursuing new and innovative ways to manage toxic and hazard material. Ladies and gentlemen, to elevate the quality of education and research at the Faculty of Agriculture, Udayana University, we must establish alliances with prestigious foreign universities. This partnership will be upgrade the expertise and competence of our academic staff, researchers, students, and graduates. Ladies and gentlemen, I extend my best wishes for an informative seminar. I'm grateful to hardworking organizing committee for making this joint lecture possible. With pleasure, I declare the open of collaborative lecture titled Chemical Pollution and its Impact to Environment. This lecture acknowledges the partnership between the master program of agroecotechnology at the Faculty of Agriculture, Udayana University, Bali, Indonesia, and the Department of Chemistry at the Faculty of Science, University Malaya, Malaysia. Thank you. Om Santi 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 Om. Wassalamualaikum warahmatullahi wabarakatuh. Selamat pagi.
Thank you very much to Professor Dr. Isnur Inyoman Udayana for giving his welcome speech as well as open the event. To Professor, if you have other activities, you are pleased to leave the meeting location. Next, we invite the Dean of Faculty of Science in University Malaya, where in this occasion represented by Head of Department of Chemistry, Faculty of Science, Associate Professor Dr. Nur Kartini Abu Bakar. Please, Professor, time is yours.
Okay, thank you very much, Mr. Moderator, for this event. Okay. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Salam sejahtera. Good morning and good days to everyone. The Honorable Dean of Faculty of Agriculture, Udayana University, Prof. Dr. I. Nyoman Gedi Ustriana, the Honorable Vice Dean of Faculty of Agriculture, Udayana University, Dr. I.R. Niluh Kartini, Professor I.R. Gusti Agung Ayu Ambarawati, the Honorable Invited Speaker, Professor Dr. I.R. Nyoman Rai, the Honorable Professor and lecturers, invitees, and all participants from both university, Udayana University and University Malaya, postgraduate, undergraduate students from both university, and last but not least, all the entire committee for organizing this event. Alhamdulillah, thanks to Allah Subhanahu Wa Taala for giving us the opportunity to be here today. I'm Nur Kartini Abu Bakar. On behalf of our Dean, Faculty of Science, University of Malaya, Professor Dr. Zulkarnain Muhammad. Would like to thank all the members of Udayana University, particularly the committee for this event, for the opening remarks in these joint lecture events on topic chemical pollutions and its impact to environment. Ladies and gentlemen, as we all know that this joint lectures event involve the postgraduate and staff, particularly from Master Program of Agro-Ecotechnology, Faculty of Agriculture, Udayana University, and postgraduate and staff from Department of Chemistry, Faculty of Science, University Malaya, Malaysia. We really hope that all participants will be able to benefit this event, being excellent in research and also academic activities from this collaborations activity. At the same time, I really hope that the collaborations between both universities should provide the opportunities to our postgraduates and also academicians to explore new knowledge and widen the network in education, research, and also for student exchange between both universities. Am I, on behalf of chemistry department staff, will inform about our program for master by coursework. We also have master by coursework known as instrumental analytical chemistry as a coursework. Can be finished within 1 year up to 2 years. Also cater for postgraduate student who interested to learn more about instrumentation, particularly in chemical analysis. We have several elective courses that also contribute to different fields, for example, color and particulates, environment, foods, pharmaceutical, focus more on the chemical analysis itself. But we also have the core course that related to analytical chemistry and involving chromatography, mass spec, that we cater about the instrumental analysis as well. So hopefully by activities like this, our both students will benefit and enhance their knowledge related to the research and also networking. And finally, I hope that the collaboration between us will continue and then will benefit both of university. I think that's all from me. Thank you. Assalamualaikum warahmatullahi ta'ala wabarakatuh.
Thank you very much to Associate Professor Dr. Nur Kartini Abu Bakar. Next agenda is presentation by invited speakers and followed by discussion led by moderator I Putu Sudiarta PhD. First of all, let me read the quick resume. I Putu Sudiarta, born in July 11, joined with Faculty of Agriculture of the University since 2005, and got his PhD degree at Shinshu University, Japan in 2011 in the field of applied biology. His research interests are molecular identification of insect pests, applied science in agriculture, biological control of pests and diseases, and biotechnology. We invite the moderator and the speaker present in this room to Professor Dr. Insinyur Inyoman Roy MS, please, to come forward. And we invite also Associate Professor Dr. Nur Kartini Abu Bakar to stay in a Webex room. To moderator, Putu Sudiarto PSD, please, time is yours.
Thank you very much for the MC for our time. So this is great honor for me to be here, to be a chairman or moderator for this student lecture. Yes, very special day, especially we can join with the uh, uh, event because we can share with other with the University of Malaya. So University Malaya is very, very high impact because this is 100 years world ranking university, so in number 65 in the world ranking. So yeah, so before we start for the joint lecture, so I would like to maybe briefly introduce for the both speaker for today for the lecture. So first is we will be kindly invited for the presentation by the Associate Professor Dr. Nur Kartini Abu Bakar. Yes, we know this come from the Department of the Chemistry, Faculty of Science, and University of Malaysia, and we'll be talking about the fit and transport of arsenic in environmental. And the second, we will be kindly invite also from, this is from Udayana University. Yeah, Professor Dr. Insinyur Inyoman Rai, MS, will be talking about the presentation of heavy metal pollution in soil and crop yield by remediation. So for the 8% or lecturer, have time 30 minutes, about 30 minutes. And this is parallel presentation. After that, we will be go to the discussion session. And for the comment or something question will be deferred by the audience. So for the time, the first I would like to kindly invite first lecture. Yes, for Associate Professor Dr. Nur Kartini Abu Bakar, time is yours. Okay, please.
Thank you, Mr. Moderator. I will share my slide first. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and good morning. Today, I'm presenting on topic under chemical pollutions and impact on the environment. So my topic that I will present today is about the fate and transport of arsenic in environment. Okay. The reason why I focus on arsenic because this is one my research work on chemical speciations of arsenic in environment because I have a project with master by coursework student on the determinations of arsenic in rice. So in today's lecture, I'm going to discuss about how arsenic will accumulate in a plant and then consumed by us as a human being through eating rice. So this is the outline of my lectures. The first of all is about the fundamental of analytical chemistry. But at the end of this talk, I will discuss a little bit about the chemical analysis related to determinations of total arsenic in rice samples. So as we all know, the arsenic is abundance in environment, mainly in earth, crust, and soil. We can see that from literature review, lots of literature review done by our scientists all over the world agree that arsenic is abundant in environment, particularly in earth, crust, and soil. And then the distributions of arsenic, when we look at all over the world, the distributions of arsenic as a metal pollutant is depending on the geological history for that particular area. And then the contributions of arsenic in environment actually come from two different sources. The first one, we call it as natural resources, natural source, and then the second one, anthropogenic activities, also contribute significantly to the arsenic release into the environment. So we will discuss later about how arsenic can accumulate in plant, particularly in rice. The physiology of plants and their growth and development are affected by arsenic. As we all know that arsenic can cause cancer and also several types of organ toxicity, such as cardiotoxicity, nephrotoxicity, and also hepatotoxicity. This is based on the previous research done by researchers all around the world. So in the environment, as we all know that arsenic exists in variable forms, both in inorganic and organic species. Okay, in different slides, I will show an example of the inorganic and organic species of arsenic. From arsenic containing compartment, plants and also rice, for example, paddy, can absorb this type of arsenic as a pollutant and accumulate in their rice itself. So the crop grown in this contaminated soil pose a several-fold higher toxicity to humans compared with drinking water. If, let's say, this pollutant enter the food chain. So we can see this is a bio magnification from the food chain. So this is the summarize from the anthropogenic activities. Largely, it's contribute from the large-scale industry, for example, mining and also metallurgical operations that contribute to the soil contamination. But we also can see that arsenic also found as a contaminants in the groundwater as well. That we all know that groundwater is one of the source for our drinking water all around the world. So this is because of the activities of human being, particularly in agriculture, by spraying these types of pesticide which contain arsenic, also from the mining or burning fossil fuel, for example, and also organic manure and also seaweed fertilizer contribute to the contaminations of arsenic in groundwater. So we can see from the literature, it seems that although we all know that most of the aquifer contain arsenic below drinking water standards. According to WHO, should be lower than 10 microgram per liter or 10 ppb. But we can see that some places, elevated concentrations up to several thousand of this arsenic concentration in ppb level are observed. More than that, even in ppm level, are observed in specific environment, notably in thermal groundwater. And its phase and transport actually are controlled by combinations of three factors. The first factor is natural processes, including redox conditions, salinity, and the pH, meaning that different area have different geological, then contribute to this factor. and also sedimentary and geochemical environment. And the last one, anthropogenic influence also contribute to this feeds and transport of arsenic in the environment. Okay, from literature, we can see that there are so many factors that contribute to the elevated or the increased concentrations of arsenic in groundwater. Perhaps the area have a thermal groundwater, or because of close or near to the mining activity, and then the groundwater actually contain tufaceous rocks, and also perhaps the groundwater is close basin with high evaporation rates, and perhaps in the delta as well. So we can see from literature that most problematic are the delta. For example, in Bangladesh, West Bengal, Cambodia, and Vietnam, because of the widespread reliance on untreated groundwater as a main source of drinking water. Okay, the direct use of arsenic containing groundwater for drinking water purpose result in elevated risk of skin disorder and various cancer. And then we also know that the increase in arsenic concentrations in groundwater also have been reported in other European countries, including Belgium and Germany. These are the literature review, the recent literature review that has a review about the feeds and transport of the pollutant, of arsenic pollutant in the environment. So if let's say we look at the geological cycle of arsenic, we can see that arsenic, once it emits in the environment, it can move from atmosphere to another sphere, for example, hydrosphere and also a lithosphere. So this arsenic as a metapollutant can move, transport from one phase to another phase. Okay, and in atmosphere, the arsenic present in the atmosphere due to natural sources, or perhaps it's come from the anthropogenic source. So we can see from this figure, from the natural source, it perhaps come from the volcanic eruptions, weathering of rocks, and also forest fire. And this is example of from the natural sources, whereas for the anthropogenic sources, it's come from industry, fertilizer, pesticide, contribute to this, the presence of arsenic in atmosphere. And then when it's rain, it will leachate to this, the soil, and then the soil become contaminated with arsenic. And then also, perhaps if let's say there's a leakage of pipe also can contribute to the contaminations in soil as well. So these are the interaction between naturally occurring and anthropogenic arsenic. Naturally, we can see that, of course, it's come from the natural, for example, this eruption, volcanic eruption, etc. Whereas it's also come the anthropogenic sources. So the movement of the arsenic as pollutant in air can reach the soil because of the rainfall. So it leads to the exposure to plant, animal, and finally us as a human being that consume plant and animals. So human being, we as well as exposed to arsenic through drinking water. So apart from drinking water, groundwater is also used extensively for agriculture irrigation. So area with high groundwater arsenic content are mainly present in Bangladesh, India, parts of West Bengal, Pakistan, China, Mexico, Canada, and United States. And crops grown in this soil have high arsenic concentration. These crops are irrigated with high arsenic groundwater and accumulate arsenic in plant tissue. So these actually have categorized by the WHO as the largest mass poisoning in a population of history when referring to the case in Bangladesh. And then the maladies commonly attributed to arsenic intake include bladder, kidney, liver, and skin cancer, as well as elevated level of heart disease. So it is believed that excessive exposed to arsenic primarily from drinking water. So this is from all around the world. Okay, now we try to understand how this arsenic can accumulate in plant. So as we all know that water on and beneath the surface of geosphere plays a crucial role in pollution and distributions of this toxic substance. So because of improper disposal of this toxic substance from the waste, it will leach this toxic into the groundwater and also at the same time will contaminate our water supply. So one of a most tragic example from this water as a vector for toxic substance in geosphere happened in Bangladesh, where when referring to this case, actually it's happened when the tube well was drilled to supply pathogen-free water, but it's become contaminated with arsenic leach from aquifer into which they are drilled and cause numerous cases for arsenic poisoning. So this is, we can see that from this figure as well. Here have been well tube sucked into arsenic containing aquifer that formations may be water contamination from the toxic soluble arsenic here. Okay, so the use of water for irrigations can contaminate soil with arsenic and provide a pathway of arsenic to get into food crop, for example, from the rice itself. So there are several mechanisms on how this arsenic get into water from the geosphere. Okay, so this is well, and then perhaps it's come from this aquifer because of the interactions with the pet and human organic matter enriched in arsenic. So probably the most common of this is the release of arsenic that can accumulate with the iron 3 oxide, what we call as goethite, which in brown and yellowish color as shown in this figure. So when the insoluble iron 3 is reduced to soluble iron 2 by the actions of anorexia bacteria on organic matter, for example, so arsenic is released as soluble arsenic in organic arsenic species, arsenic 3 and arsenic 5. So the oxidations of arsenopyrite can release arsenic as well as from decompositions of arsenic contaminated organic matter that's here in the underground deposited. So this is equation that show that this is what we call as iron 2 oxide that can react with the organic matter, particularly in pit and human organic matter, will release this iron 2 aqueous soluble species iron 2 and also arsenic, whether in arsenic 3 or arsenic 5 species. So from literature review, it says that there is a bioavailability of arsenic in plant have been reported by Rashid and colleague when these researcher actually study the human exposed to different inorganic and organic arsenic species. For example, arsenic 3, arsenic 5, MMA is monomethyl arsenic acid or dimethyl arsenic acid DMA, and also arsenobutane and total arsenic. So these are the species of arsenic that can may be present in the environment. and also in plant. So they reported that nearly 90% of water resources were contaminated with arsenic level that exceeded the provisions guideline of WHO. With this, the should be for drinking water should be lower than 10 ppb. Additionally, 60% of rural residents were exposed to arsenic concentration that exceeded the provision tolerate daily intake defined by WHO. And also study by Giorgio Lee and co-researcher reported that arsenic biotransformations by the human enzyme SAM and also methyl transferase into methyl arsenide and also dimethyl arsenide. Also may occur in liver and also protected against potential and short-term arsenic exposure. So this have been studied by previous researcher. So there are several factors that contribute to the bioavailability of arsenic in plant. Different forms of arsenic may have different rates of absorptions in aerobic and anaerobic environment. But we can see that from literature that arsenic 5 predominates in aerobic soil, whereas arsenic 3 predominates in an aerobic environment. So there is always a possible of interconversions of these two forms depending upon redox potential, pH, and also biota factor microorganism that present in soil as well. So these arsenic species are also a high affinity for oxide, for example, arsenic 5, which are more affinity than arsenic 3 species. And then arsenic immobilizations is favored when arsenic 5 is co-precipitate with iron 3, iron 2 ions. So dissolved organic carbon also will accelerate the mobility or transportations of arsenic and render its bioavailability in plant. So the presence of iron plug in a rhizosphere also contribute to the arsenic absorptions through the roots by sorbent process. This is we see the how arsenic accumulate in plant. However, several methyllate species are also present along with arsenic 5 and arsenic 3 in soil solution, which can readily be taken out by plant, lower invertebrate and also small animal. So all these factors actually led to the arsenic accumulations by plant, which subsequently enter the food chain that we actually consume as a contaminated food. So in order to understand the phase and the distribution or the movement or the transport of arsenic, we should understand that we can determine the concentrations of arsenic as a total concentration or speciation by just focus on the predominant species in the environment or in rice, for example. So the total arsenic actually can be divided to organic and inorganic species. When we talk about organic species, it can be arsenosugar, arsenobutane, and arsenocholine. Okay, that is naturally found in environment. Okay. And then also in organic species, for example, arsenic 3, arsenic 5, and also monomethyl arsenic acid and dimethyl arsenic acid. So this is the common species that can be found, naturally occur in organic and organic species. But we can see that if we study the toxicity of the arsenic, the organic species is not toxic. Only the toxic species is the inorganic species of arsenic. So if let's say we do the analysis from the drinking water and we found that the total concentrations of arsenic in the drinking water is higher than 10 ppb, meaning that is exceeded the permissible limit as mentioned as referring to the standard of WHO. We cannot say that we drink the toxic arsenic because we didn't know whether the total arsenic is come from the organic species or inorganic species. We have to confirm, if let's say we do the determinations and find the total concentrations is exceeded 10 ppb, then we have to go for speciation study to determine the predominant species of arsenic present in that particular sample. And then after that, we identify the predominant species, and then from there we can study the risk assessment of the species in the environment or in the plant or in the human. Okay, so this is about the risk assessment and toxicity study. So when we look at the biomarker of water pollution referring to the arsenic, so biomarker as I provide evidence of pollution, either from the accumulations of the arsenic in water and their metabolite in organism, or the effects on the human being who exposed to that particular pollutant. So we call it as a biomarker. So in this case, we also can identify the biomarker from the area contaminated with soil by collecting the plants that actually harvest from that particular area. Okay, so we can say that we can also get paddy field and then cut the plant leaves or roots, or also we can get the fruits, rice itself, to determine the concentrations of arsenic in this plant. And then this actually this slide actually share with us about the biomagnifications study, which involve the food chain, okay, because it will accumulate in the high level of the large mammal. For example, this is not arsenic, but just I want to share with you how arsenic also other pollutant that contribute accumulate in our human body or the animals by process of the biomagnification. Yeah. So this is example of osprey. This is a bird that's normally we use as a biomarker for identifying the pollutant in water system. And then this is example F bioindicator. And then this actually to different this slide actually try to give us the differences, try to explain the differences between biomagnifications and bioaccumulation. When we talk about biomagnification, when we do the research to focus on biomagnification, meaning that we have to study the concentrations of the arsenic in each level, from the higher to the lower tropic levels in the food chain. But if we study the bioaccumulation, we just focus more on the plant itself. For example, I study the rice, the arsenic in rice, for example. So I just focus on that plant, okay, only. So we call it as bioaccumulation. The build-up of chemical within tissue or organ of the body result in a resistance to breakdown and slow excretions rate. So this is the movement. This slide actually want to tell us the effects when this metal ion or arsenic accumulates in our body, for example. Different when we compare with organic pollutant, for example, PCB and arsenic. So the movement of PCB as organic, neutral organic compound, when it transport from one place to another place, or it change to the from the parent compound to the metabolites, actually in terms of the chemical and physical properties of the metabolite is actually not quite changed in terms of the chemical and physical properties metabolite with their parent compounds for the organic compound, for example PCB or dioxin. But for the metal, if let's say it's from the arsenobutane to the arsenic 3 of, for example, when it changed to one species to another species because of the transformation or biotransformation, actually the properties of this species totally different. Okay. So their reactions product are often very vastly different chemical and physical properties based on the metal itself. That's why I think metal accumulations is quite danger to us if accumulate is our body. So a few minutes, perhaps allow me just 5 minutes to share with you the result that we get from the determinations of arsenic as a total concentrations of arsenic in rice sample using instrument continuous flow hydride generation coupled with electrothermal AAS. So this is actually done by my student. Okay, I think we just focus on, this is the sample prep that we have done. Of course, the same sample prep, we just grind and then sheaf and then dry in oven. For the difference between the difference or novelty of this work, actually we developed our own methods on how to extract arsenic using the microwave. And then in this study, actually, we study the effects of nitric acid as acid digestion method that we use, acid we use for digestion, the effect of nitrate and nitrite, whether it suppress or not the signal of arsenic when you use the instrument for detections of arsenic after the extraction in the sample prep. Okay, so this is the objective of the study. Okay, so when we look at literature review for the sample prep that we use for the to do the sample prep for rice, actually we can use a dry ashing, slurry, or microwave digestion, or extractions with water bath at certain temperature for certain hour and also centrifuge. Okay, so in our study we use the microwave. So I will share with you the method that we use. The instrument that we use is hydride generation coupled with AAS. And the for sample prep, we use a microwave digestion. And then in this study, actually, we investigate the influence of nitrate and nitrite on the arsenic signal in the AAS that we determine the analyte. And then in this method, we add additional reagent, what we call as a sulfamic acid, to see the effect of adding this sulfamic acid to the during the sample prep. And after that, we do the metric validations and apply to the real sample. So this is the optimization for the system graphite furnace that we use, and also for the graphite, and also for the electrothermal AS that we use. And then this is a parameter that used for the hydride and also for the microwave digestion. And the result that we get here based on the this actually we optimize the reactions and lot time to get the optimum conditions for the reaction time. For the microwave digestion, we do optimize, and then by changing the concentrations and also the combinations of with or without sulfonic acid in the digestion, we can see that by using sulfonic acid, it will increase the signal. Because of, as we all know, that the presence of nitrate, or actually the signal will be suppressed. So this is the result that we get from the study, the influence of nitrate and nitric ion on the arsenic signal. And then, so when we add, you can see the difference when we add the sulfamic acid. So meaning that by using sulfamic acid, it actually can react as a masking agent to minimize the signal suppression's effect of this process. And then from the method validation study, we did do several parameter, including selectivity of the and also linearity. Yeah. So these are the result that we get. And then it seems that from the result that we actually have done two different sample origin from Thailand. This is a white rice polish sample, and we can see that total arsenic concentrations obtained in this study is similar to reported by previous researcher done in 2010. And then the result obtained from this study shows that it's lower than the permissible limit regulated in Malaysia, which is 1 microgram per kilogram arsenic for food, for other food category. But if let's say we consume for the children and baby food, basically this is a borderline. Because permissible limit for the baby food is 0.1 microgram per kilogram. Meaning that the method that we study actually suitable for determinations of total arsenic in rice. And so this is the conclusions for this study, and then reference. And thank you for your attention.
Okay. Thank you very much for Prof. Kartini. So yeah, I think now audience have many questions, but we should be keep this one because we should be here of our next lecture for Professor Rai. So yeah, please keep if you have the question or something comment for the, I think it's very interesting topic. So maybe you have yeah idea or something like that. But now we should be continue for the next lecture by Professor Inyoman Rai. So, time is yours, Professor Nyoman Rai. Ah, yes. I'm forget for the sharing.
Yes,
Would
yes,
you
I
like
will
to
start sharing.
stop? Yeah. Okay. Okay.
Okay, thank you.
Please, Prof. Rai. Yes. Thank you.
Om Swastiastu. Thank you for time. The Honorable Associate Professor Nur Kartini Abu Bakar. Selamat berjumpa, Ibu.
Ya, selamat berjumpa kembali.
Selamat berjumpa
Masih
kembali.
ingat ya?
Oh, masih ingat.
Masih
Ibu
ingat ya?
datang ke Udayana sama tim dulu ya.
Ke Rosazlin ya.
Okay. The Honorable Moderator and so our head of master degree participant. Malaysia, almost of Malaysian people, I think, also use Indonesia and Melayu, I think. So I will speak both in English, maybe also in Indonesia. As introduction of my paper, the higher community activities, for example, in agriculture, industrial, factory, trade, the household, and others, I think housing waste production also be higher. So decline or decreasing the quality of environment, physically, chemically, and also biologically. heavy metals, for example, plumbum, cadmium, chrome, cuprum, and so ferrum maybe, is one type of which generated from various community activities. This waste, this pollution, this pollutant come from pesticide and also from water irrigation, and then accumulated in rice field, in soil, and then absorbed by the plant, and so stored in their organ. If the accumulation in the organ consumed by the human, I think it's very dangerous for the health of consumer. Like this picture, I also know that the pesticide is as the source of heavy metal from our agricultural land. In Bali, for example, Badung River would downstream flow in the middle of Denpasar city, and the water is for irrigating our rice field in the northern part of Denpasar city. And my student Widyasari 2023 have already analyzed of rice field which got irrigation from Badung River. And there is indication that our rice field have already polluted by heavy metals. Jadi Bapak Ibu sekalian, baik yang ada di sini maupun di secara online, sudah dilakukan semacam analisis terhadap sawah-sawah kita yang di hilir daripada Sungai Badung yang mendapatkan pengairan di Sungai Badung. Terdapat indikasi bahwa tanah-tanah sawah kita atau tanah-tanah pertanian kita yang mendapatkan pengairan dari Sungai Badung telah terpolusi oleh logam berat. And then our student also analyze the content of heavy metal in various organ of rice and so in corn. And there is indication also the heavy metal have already contained at various organ of rice and so in corn. To clean up of heavy metal in agriculture land, bioremediation can be done. The bioremediation is a technology for cleaning soil and water pollutant, including heavy metals, by using hyperaccumulator plant. According SARMA 2015, hyperaccumulator plant can clean heavy metal by 5 mechanisms: phytofiltration, phytovolatilization, phytodegradation, phytostabilization, and rhizofiltration. Hyperaccumulator plant clean by absorbing and storing heavy metal in their organ, and have already known that accumulator plant can absorb heavy metal enough high of their dry weight. And the mechanism divided into 3 process. The first one is absorption by root, and then second one translation of metal from the root to the other plant part, and then location of metal. Jadi Bapak Ibu, tanaman hiperakumulator ini bisa membersihkan polutan atau heavy metal atau logam berat yang ada di tanah-tanah pertanian kita. Seperti yang saya sampaikan tadi, sudah ada indikasi bahwa tanah pertanian kita khususnya rice field, ya sawah ya, yang mendapatkan pengairan dari Sungai Badung itu sudah terindikasi adanya logam tanah, tapi juga pada bagian-bagian tanaman, daun, akar, terutama juga pada filtration. In this filtration, accumulator plant absorb the heavy metal and then transferred, stored in the canopy like this. This one is phytovolatilization mechanism. Dalam mekanisme phytovolatilization ini, the plant absorb heavy metals and then convert it into steam and then transfer to the atmosphere. Jadi pada mekanisme volatilisasi ini, polutan itu diabsorpsi oleh tanaman, kemudian secara fisiologis diubah dia menjadi bentuk uap, lalu ditranspirasikan ke udara. And then at the mechanism phytodegradation, the hyperaccumulator plant absorb heavy metal and then degraded into harmless compound. Jadi diubah menjadi senyawa-senyawa yang tidak berbahaya melalui degradasi dia. In mechanism of phytostabilization, the accumulator plant absorb the heavy metal and then stored in root, not move to the canopy. Jadi just stored in root. Jadi hanya disimpan dalam akarnya, tidak dia ditransport ke pucuk. And then the last filtration mechanism, similar to phytostabilization mechanism, but in other kinds of plant. In filtration mechanism, the plant is grow in water medium. But in phytostabilization, plant grow in soil. Several type of hyperaccumulator plant can grow and adapt to soil contaminated with heavy metal. But each plant has a different ability. There are many kinds of hyperaccumulator plant. Terrestrial plant, and then submerged plant, and so on. Jadi Bapak Ibu sekalian, jenis-jenis tanaman hyperaccumulator ini ada banyak macamnya. Jadi ada tanaman darat, for example hanjuang, kalau kita handong merah ya. And then puring, in English is proton. Lidah buaya, sansevieria, bunga matahari, sunflower, and the part of this plant have already researched by my student to remediation of heavy metal in rice field, which the land get irrigation from Badung River. Ini juga berbagai contoh tanaman-tanaman hyperaccumulator. Ini tanaman yang digunakan untuk memfitoremediasi ketika logam beratnya itu ada di dalam air. Ini submerged plant, and then emerged plant. Ini emerged plant ini adalah tanaman-tanaman yang hidupnya tergenang seperti padi dan lain sebagainya. Dan yang terakhir adalah free floating plant. Free floating plant ini seperti gambar ini, ya, ganggang dan lain sebagainya. It is very effective also for remediating heavy metal from our land, our soil, our agriculture farm. This is the research of my student regarding phytoremediation of heavy metal Tb, Cu, Cd, and Cr using hanjuang, sansevieria, proton, and sunflower. Jadi salah satu mahasiswa bimbingan saya di S3 meneliti tentang mempitu remediasi logam berat PBCD, CU, dan CR dengan menggunakan nandong merah, lidah mertua, kemudian puring dan bunga matahari. This research was done by using soil taken from Badung River and then bring to the greenhouse in Pegok. There are three important things we can get from this research. The first one is from activity of the student in analyzing of various part of rice and corn to analyze the content of heavy metal. From this research, we can show the result is like this photograph. In rice plant, there is some heavy metals, root, stem, no heavy metal in the stem, but there is in root, leaves, and so in seed. But in corn plant, the heavy metal accumulate in root, stem, and leaves. Bapak Ibu sekalian, kalau kita lihat datanya ini, jadi tanaman-tanaman yang diambil dari yang budayakan petani di daerah hilir dari Sungai Badung, saya minta untuk bahwa pada biji padi itu hanya CU yang tinggi. Sedangkan PB, CD, dan CR relatif tidak tinggi, tetapi karena dibuat dalam bentuk histogram tidak bisa kita lihat. Ya. Tentu ini sangat berbahaya, oleh karena CU-nya sudah lumayan tinggi sampai 23 mg per kilogram. Dan pada tanaman jagung, Bapak Ibu sekalian, we can see here that in corn plant, there is many heavy metal accumulate in various organ of the corn plant. Very complete in roots. There is 4 kind of heavy metal: PB, CU, CD, and CR. Also in stem, but only CU, and so in leaf only CU. What mean of our data here? This means that very dangerous for animal, for example cow, ya. Seperti kita tahu bahwa petani-petani yang ada di daerah hilir Sungai Badung, batang tanaman jagung yang sudah dipanen itu digunakan untuk makanan ternak, ya. The stem of the corn after harvesting by the farmer is used for animal feeding for cow. So what mean our data here? Jadi artinya adalah ketika dalam jangka panjang batang jagung yang dipanen dari sawah itu digunakan untuk makanan ternak, maka daging ternaknya itu mengandung logam berat. So it is very dangerous for human health. Ya. Tidak hanya pada padi, tetapi pada jagung, kalau dia pada batangnya digunakan untuk pakan ternak, maka menjadi sangat beracun bagi manusia juga. The second one of the important thing we can get from this,
thank you.
from the activity of my student to analyze the soil from rice field was taken for growing media in the pot in greenhouse, and then the pot planted by 4 kind of accumulator plant, Hanjuang, Sansevieria, Croton, and Sunflower, and then injected with EP metal like this, 1,100 ppm, 1,300, 1,500 ppm injected by this ppm, and then after 4 months, the accumulator plant harvested, and then measure how much of EP metal accumulate in various organ of each accumulator plant. From this picture, we can show that Hanjuang is the best accumulator plant for cleaning heavy metals, especially for PB and CD, maybe also for CR. But sunflower also good enough for cleaning CU and CD. Jadi Bapak Ibu, ketika lahan sawah kita tanami dengan Hanjuang dan juga dengan jungga matahari ini, maka ini bisa mengangkat, bisa mengcleaning logam berat yang sudah terakumulasi di sawah, yang sumbernya bisa dari pestisida, bisa dari air irigasi. The third one, important thing we can get from the research done by a student is the student measure BEF and EF. BEF is BEF itu adalah perbandingan antara heavy metal yang ada di masing-masing organ tanaman dengan yang di tanah, ya. Bioaccumulation factor. The bioaccumulation factor is the ratio between the content of heavy metal in various organ of plant and in the growing media. And TF transfer TF is the ability of a plant to transport the heavy metal to the canopy. Jadi BAP itu merupakan perbandingan antara jumlah logam berat pada pucuk dengan yang di tanah, sedangkan TF itu adalah kemampuan dari tanaman hiperakumulator untuk mentransport EP metal itu ke bagian pucuk. Nah, berdasarkan atas pengukuran itu, we can see from this photograph that Hanjuang is very good hiperakumulator plant for decleaning, especially CD, because cadmium, you can see here, the value of BAF is very, very high. This means that Hanjuang can absorb very high of CD, and so can transport very high PB, CU, and CR to the canopy. The other of my student also do research about remediation of heavy metal with biochar made from banana waste. Jadi satu lagi mahasiswa bimbingan saya minta untuk meneliti tentang remediasi logam-logam berat yang mengakibatkan pengairan dari Sungai Badung. Kalau tadi kita menggunakan tanaman hiperakumulator, hasilnya seperti tadi, kita coba menggunakan biochar made from banana waste. Biochar made from banana waste divided into 4 kinds. The first one is made from stem of banana. Banana after harvesting the fruit, it is the waste of banana, and then the stem is for making one kind of biochar. And the second one is the material, the source of which is the fruit peel, kulit buah. The third one is making from tandan, fruit tandan buah, fruit buns. And the fourth one is combine between stem, fruits, fruit branch, fruit fields to be one. So there are 4 kind of biochar made from banana. And before application to the soil, to the land of agriculture, the eggs of biochar biochar observed by using SEM and spectrometry to know about the physical and chemical properties of the biochar. This picture show that the physical of X kind of biochar. This is from banana stem. This is from fruit buds dari tandan buah. This is from buah, and this is mixed from 3 kind of waste of banana. You can see here that X of biochar have different physical properties. Dan kira-kira sangat berbeda dia kalau kita lihat dari gambarnya yang sudah diperbesar karena ini diperkecil. Dan menurut saya sifat fisik yang sangat menentukan dari biochar baik atau tidaknya adalah the number of pores, jumlah dari pori-pori. Sepertinya kalau kita lihat dari gambar biochar yang terbuat dari campuran batang pisang, kemudian kulit buah, dan juga dari tandan buah yang terbaik dari segi jumlah pori-porinya. And then this is the, beside testing the physical characteristic using SEM, the biochar also observed by spectrophotometry. The result is like this. X of a kind of biochars have very different chemical properties indicated by the different of moisture, ash, volatile, and so carbon, like this. And then this is the data. Biochar then applicating to the pot, and the metal in the soil measure, and the data is like this. You can see that control, there is a high of PB. Bapak Ibu sekalian, jadi berdasarkan atas data ini, pot-pot tadi yang diberikan berbagai jenis biochar, kombinasinya dikombinasikan dengan kompos seperti ini. Ini adalah biochar dari batang, BT ini adalah biochar from stem, and then KL ini adalah biochar dari kulit buah, sedangkan yang TN dari tandan buah, sedangkan yang C adalah campuran. Masing-masing dikombinasikan dengan kompos 5 ton, 10 ton, dan 15 ton. Ini diteliti di pot, kemudian kita lihat hasilnya seperti ini. Jadi sangat mengagumkan sebetulnya penggunaan biochar dalam hal mendecline, to decrease the heavy metal in the soil. Jadi tanahnya juga diambil dari lahan sawah yang mendapatkan pengairan irigasi dari Gedung River. Kita lihat di kontrolnya yang tidak diberikan biochar, tidak diberikan kompos, very high PB, like this. Di penelitian kombinasi perlakuan yang lainnya hampir tidak ada ya, memang tidak terdeteksi kecuali pada biochar yang terbuat dari tandan dengan kombinasi kompos 15 ton. Ada sedikit, tapi secara umum pemberian biochar very effective for cleaning of heavy metal from the soil. Juga pada CU dan CD, pada kontrol tinggi ya, tetapi memang ada beberapa yang lebih tinggi dari kontrol, tapi secara umum lebih rendah. Demikian juga CD. Tetapi Bapak Ibu, but this is unexpected of result. You can see here that heavy metal in corn kernel of jadi kita ukur juga pada biji jagung. You can see here that the control not detected. This means that without biochar and compost, there is no PB in corn kernel. But by treatment biochar and so compost, PB in corn kernel is very high. I think that's unexpected result, but we can explain this data. Maybe barangkali Bapak Ibu sekalian, pada tanah-tanah atau pot yang diberikan biochar dengan batang dan juga dengan kulit buah, itu semua logam berat yang ada di tanah bisa diekstrak oleh si biochar itu dan juga oleh komposnya. Kemudian setelah diekstrak diserap oleh tanaman. And then transported to the canopy. So we can see here that very high PB in corn kernel. Not only to the canopy but also to the seed of the corn kernel. Ya. Jadi kira-kira seperti itu. Demikian juga CU. CU ternyata pada kontrol 135, tetapi pada BT dan juga KL ini tinggi. But there is one package of treatment combination that biochar from making from mix of stem and then fruit bun and fruit skin. This is CA, campuran dari batang kemudian kulit buah dan juga tandan buah. Itu ternyata menyebabkan PB tidak ada di biji. This means that this treatment can be applied for the cleaning of heavy metal in soil, and then the heavy metal not transported to the seed, something like that. Jadi Bapak Ibu sekalian, ada satu paket perlakuan yang menarik di sini, yang terbuat dari biochar yang terbuat dari campuran batang, kulit buah dan juga tandan buah. Jika kita berikan pada lahan pertaniannya itu dibersihkan dari logam berat, khususnya PB, ya. Lalu logam berat yang dibersihkan itu tidak dibawa ke biji. So very safe for cleaning of heavy metal in the agricultural land. I think very good for cleaning of heavy metal, especially PB. The last, one of my students also do research about wetland constructed system. This system is combined physically, chemistry, and biologically, including phytoremediation. He planned like this. Jadi ada penelitian di lab, juga ada penelitian di lapangan. The wetland constructed system like this is using for cleaning waste at the pig farm. Jadi pada ternak babi, ya. Kemudian hasilnya itu digunakan untuk meningkatkan produksi cabai. Masih sedang berlangsung. Dan berdasarkan hasil penelitian Titah 2022, Titah state that wetland constructed system is very effective for decreasing or for declining of waste, especially the waste or pollutant come from pesticide. By using this method, this is the simulation of the method, and this is the real of research which is done by Titah 2022. This is the reference. Thank you very much. Inilah buku saya yang baru saja terbit minggu ini, yang di dalamnya juga diuraikan tentang fitoremediasi. Jadi hubungan antara nutrisi tanaman secara umum, lalu kalau nutrisi tanaman itu dicawe-cawe oleh PB, CD, CU, CR, FE, dan sebagainya, kalau terlalu banyak di tanah, maka hara-hara nutrisi yang penting seperti NPK, CMK juga terpengaruh. So very important how to decreasing the declining of heavy metal. And I have already wrote in my book, dan sekarang sudah tersedia secara online. Ini bekerja sama dengan salah satu penerbit. Terima kasih Bu Rindang atas informasinya. Thank you very much.
Thank you very much, Professor Rai. Very interesting topic. Yeah, because we every day with the chemical in how to control pest and disease sample, and he talking about the how to use the plant to remediate. Very very interesting. So I think now we open for discussion for the all participant for the two topics for from Malaya and also from Udayana University. So please, yeah, this method is raise hand from this and also can write in the comment. Okay, so please.
Halo Pak Bedu.
Okay,
Halo.
one is Professor Santos already have maybe a question or some comment. So please.
Thank you very much for the time to me. Good day, everyone. The topic is very interesting. Very interesting. We have two speakers. Very excellent. Yeah, excellent. Yeah. My question at the first is, we say in Indonesia. Nah, Prof. Rai ini menjelaskan terkait dengan pencegahan polusi daripada logam berat. Nah, menarik sekali nih, dan tadi ada beberapa metode yang disampaikan. Nah, sekarang ini yang kita dapatkan informasi, keefektifan daripada metode ini bagaimana? Dari metode ini yang keefektifannya berapa dan yang mana paling efektif? Nah, yang kedua, seandainya keefektifannya kurang, artinya tidak 100%, berarti tidak bisa menyerap logam berat secara keseluruhan. Nah, ini berarti logam beratnya itu dia kan kalau kita nanam padi itu di sawah. Nah, ini otomatis akan diserap oleh tanaman. Setelah dia diserap oleh tanaman, kalau kita tanam padi, nah ini kan akumulasinya pada batang, terutama juga pada biji. Nah, setelah ada pada tanaman pada biji ini, bagaimana cara mengatasinya? Thank you very much, Pak Betul. Yeah.
Okay, I think is directly maybe because may have at least two questions, Prof. Right? So, but first is how about the method, and second is effective method which one, and also if you have the seed contaminant or something, how to solve this problem like this one. Okay, please.
Thank you, very nice question. I will answer by Indonesia maybe. Dari sebetulnya bukan dua ya. Jadi ada beberapa bimbingan saya yang sudah meneliti. Saya di lingkungan itu khusus tentang fitotoksik pada produk-produk pertanian. Pertama itu sebetulnya ada bimbingan S2 yang meneliti tentang bagaimana penggunaan pestisida yang sangat tinggi, terutama di daerah bukan yang di Mengui ya. Mengui kebetulan dia sebagai guru, as teacher at Green School. Jadi Green School itu memang betul-betul bagaimana membuat lingkungan pertanian, lingkungan secara umum termasuk lingkungan pertanian not decreasing while using, but conserving while using. Jadi istilahnya dia itu ketika menggunakan tanah pertanian tidak terdegradasi, not decreasing while using, tetapi conserving while using. Nah, konsep itu kemudian dicoba untuk pada padi. Saya minta untuk mengambil beberapa lokasi hasil padi di daerah Kecamatan Mengui, kemudian dianalisis. Lalu memang sangat bersyukur bahwa di situ tidak ada logam berat terakumulasi di biji padinya. Saya lalu tertarik, kemudian kita arahkan di downstream di daerah hilir daripada Sungai Badung. Pertama kita minta menganalisis airnya Sungai Badung itu, dan sangat terkejut apa yang sudah disampaikan oleh Dinas Lingkungan Hidup baik Provinsi Bali maupun Denpasar, sudah ada indikasi terpolusi berbagai limbah organik dan juga terpolusi oleh
logam berat.
Mungkin tanda kutip ada logam berat tetapi masih belum di atas baku mutu. Sebetulnya masih aman. Ya. Tetapi ketika air yang sebetulnya masih aman, cuman sudah ada polusi terutama logam berat digunakan untuk mengairi terus-menerus, using for watering continuously from day to day, from month to month, and all year. Yeah. So we can see that the plant will absorb the heavy metals and then transport it to the various organ of plant in the canopy. One of them is at economic yield. For example, in rice is gabah, bijinya, and then in corn is kernel. And so
Yeah.
I suggest my student to analyze of content heavy metal in some vegetable. Ya. Tapi yang menarik pada dua tanaman ini. Pak Promura, pertanyaannya dari beberapa riset yang sudah dilakukan oleh mahasiswa, terutama adalah tentang penggunaan tanaman fitoremediasi. Itu sekarang sudah dipublish di jurnal, bukan publish, masih sedang jalan publikasinya, saya bawa ke Scopus ya, dan sudah perbaikan tidak ditolak. Mudah-mudahan setelah perbaikan ini tidak ditolak lagi, artinya tidak ditolak, kalaupun masih ada perbaikan, masih ada harapan untuk diterbitkan. Jadi itu kita masukkan ada perbaikan ya. Jadi intinya adalah dengan fitoremediasi ini tanaman hanjuang dan Sansevieria sangat bagus untuk cleaning, membersihkan PB, CD, CU, CR. Oleh karena apa? Mereka dapat mengabsorpsi banyak logam berat dan ditransport ke berbagai bagian tanaman. Karena dia Sansevieria dan juga hanjuang tidak kita makan, tidak masalah. Lalu saya minta mereka membuat simulasi, sedang dibuatkan simulasi sekarang. Kalau kita punya tanaman sawah 1 hektar, lalu per individu tanaman bisa menyerap berapa miligram tadi. Kalau kita tanam dengan jarak tanam 1 meter kali 1,5 meter seperti biasa, kalau di tempat-tempat tanaman penjual bunga-bungaan, tanaman hias itu, bagaimana dia menanam hanjuang sebelum dibawa untuk landscape begitu ya. Saya minta cukup misalnya 1 meter kali 1 meter. Lalu sedang dihitung sekarang berapa kilogram per hektar bisa menyerap tanaman apa namanya heavy metal tadi. Nanti hasilnya akan mengejutkan saya kira. Itu tentu tidak bisa dipungkiri oleh karena data berbicara. Tanahnya kita ambil dari situ, kemudian kita tanaman juang, berapa mereka menyerap logam berat. Nah, pertanyaan Pak Prof. Santoso yang menarik adalah, mana yang efektif? Tadi kita sudah lihat, sebetulnya penggunaan biochar ini, tanda kutip, ada semacam green light, ada lampu hijau. Terutama tentu memilih jenis biochar. Buktinya yang tadi, biochar yang terbuat dari campuran batang, kulit buah dan juga tandan buah, itu ternyata bisa mendeclining hampir apa namanya sempurna EP metal yang ada di tanah, oleh karena tidak terdeteksi sama sekali adanya PB terutama.
100% Prof. Ya.
Tetapi setelah di cleaning dari tanah, tidak ditransport ke tanaman jagung. Ini artinya kan dalam pikiran saya, biochar yang terbuat dari campuran ini mampu mengabsorb, menyerap logam-logam berat itu menjadi aktif dalam pori-pori tadi. Oleh karena secara fisik, salah satu variabel dari baik tidaknya biochar itu adalah how many spore, berapa jumlah pori-pori yang ada dalam biochar itu. Kalau dia pori-porinya banyak, jutaan, mungkin triliunan begitu dalam dalam jumlah tertentu, maka logam berat yang dibersihkan dari tanah itu bisa jadi dimasukkan ke pori-porinya itu sehingga tidak diserap ke bagian tanaman yang bernilai ekonomi. Lain dengan yang kalau dia terbuat hanya dari batang. Oleh karena tidak lengkap, dia mungkin batang itu bagaimana seratnya dan sebagainya. Kemudian kalau hanya tandan buah, kalau hanya kulit buah, dia mungkin pori-pori sedikit sehingga bisa membersihkan logam berat dari tanah, tetapi tidak disimpan di dalam pori-porinya itu, tapi diserap oleh tanaman. Jadi sebetulnya ini mekanisme yang luar biasa menarik dan perlu kita teliti lebih lanjut. Bagaimana kira-kira kok bisa yang campuran mampu seperti itu, sedangkan yang dari sendiri-sendiri kok seperti itu. Ini juga nanti terkait dengan bagaimana metode membuat biochar yang baik. Bahannya dari apa? Tidak cukup mungkin dari satu jenis bahan. Bahannya kita harus combine untuk mendapatkan sifat fisik dan kimia yang bagus. Saya kira seperti itu, Prof. Terima kasih.
Thank you very much for the information, for the answer, Pak Prof. Rai. Nah, terus yang kedua belum barangkali ini Ibu Prof. Nur Kartini Abu Bakar ya. Kalau dia sudah lolos, sudah sampai ke biji misalnya membuat tanaman, nah ini gimana cara mengatasinya? Iya. Terima kasih.
Please Bu, Prof.
Okay,
Kartini.
terima kasih Profesor Santosa. So, okay, saya kira for me the prevention's better than cure, right? So meaning that in order to avoid, because of when apabila metal ataupun logam berat tadi telah berada pada buah, of course kalau boleh jangan makan, kan? If let's say it is a fruit, let's say avoid to.
Aman.
If let's say it's cultivated, avoid to. Right. But for me, actually, we try to avoid the contaminants to enter the environment, right? So prevention is better than cure. So once it's present in environment, that we need to do the remediation, right? But for me, the best thing is try to avoid the source. That's why we have to know the source of the pollutant, or where it comes from, right? So we try to avoid from the pollutant to enter the environment. Once we do this by regulations by the government, and we as a public have to aware about the consumptions of certain pesticide that's perhaps cheaper than a certain pesticide that contain high concentrations of heavy metal. for agriculture, and then also the we call as pesticide management in agriculture, or also pesticide. We have to educate our farmer about awareness of using excessive amount of pesticide, also fertilizer in agriculture activity, in order to minimize the pollutant from entering the this plant, right? So I think is another way in order to, before it start exist in the environment. So we need to do the we have awareness, public awareness among farmer, educate them to use the try to because we have to know before we start we want to because if, let's say, once we know that is exists in the environment, of course we have to do some actions in order to go for the bioremediations and other technology in order to try not avoid them to go through our food chain, right? But I think the best thing is we educate our nation, public, our children, in order to how to minimize, for example, if, let's say, it's come from the fertilizer and pesticide, so we educate them on how to use it properly, and then how about the container after use, and avoid to mix these pesticide container used for other use. Also, it can contribute also. So I think the best thing we prevent, better prevention is better than cure. I think that's all from me. Thank you.
Thank you. Thank you very much for the information and for the answer. Yeah, thank you very much.
Okay.
Waktu dikembalikan lagi Pak Putu, dan
Thank you
sekaligus
very
Pak Putu, tiang izin Pak Putu karena ada kegiatan lain yang harus dikerjakan. Sebentar juga jam 1 biar bisa rapat ke fakultas nggih. Tiang izin duluan ya.
Okay, thank you very much for Prof. Santosa and also for the Prof. Rai and Prof. Kartini. But before Prof. Wijaya, this one still have the question from chatting from Messenger. This is come from Dr. Niluh Kartini. Yeah, the same name with the Prof. To Prof. Kartini, maybe you already answered, but maybe
Yes.
more deep about the information, maybe addition information about the any research related to reducing arsenic or metal pollution. I think this same, but maybe you can add information about this one. Okay, thank you.
Okay, thank you, Mr. Moderator. Actually, I think I already answered the question, but for the time being, I didn't do any research work on the bioremediation. I just focus on the chemical analysis, meaning that the method development on monitoring the arsenic, for example, or other pollutant in environment. More focus on the method development on how to detect or determine the concentrations of pollutant or unlike at very low concentration using high-end instrument, and also do modifications for the sample prep, for example, or instrument in order to determine the concentrations at very low concentration. So I think I already answered the question by Prof. Niluh Kartini. Yeah. And then can I have 1 minute? I think it's a good sharing session by Prof. Rai, okay, about the bioremediations. And I think the work done by Prof is very good, because it's actually using the biomass from the agriculture, and then go back converting the biomass to the valuable material, right? And then it can be used back to the agriculture. So I think that's all from me.
Yeah, the maybe will be add from Prof. Rai, because this related with how to make this solve problem. Okay, because Professor Kartini just how to detect chemical aspect and also
Yes.
preventive how to educate the people reduce the chemical using for the pesticide and for the insecticide like this one. Okay, Prof. Rai, maybe add information about this one. Okay, thank you.
Thank you for Ibu Kartini, I think same name with Associate Nur Kartini. Uh, yes, right. I think Bu Kartini wrote at the chat wastewater garden. If we read at the journal, I think wastewater garden is a traditional method to decline in increasing pollutant, not just heavy metal but also other pollutant. And right now have already developed similar to wastewater garden is about constructed wetland system. Jadi semacam apa ya? Semacam mirip seperti wastewater garden ini, constructed wet system ini, the combined way to decrease of the pollutant by using chemically, biologically, and physically process. Because at the constructed wetland system, there is consists of a plant pitu accumulator plant. And so the growing media also there is soil and then gravel, something like that. So if pollutant through to the wetland constructed system, the pollutant will absorb physically by the soil and by the gravel, and then absorbed by the plant through pitu remediation. And so bereaksi, something like that. Dan wastewater garden yang sifatnya tradisional ini saya kira sangat luar biasa. Tinggal sekarang mengembangkannya menjadi sebuah metode yang sesungguhnya bisa dalam bentuk reaktor mini, tapi juga bisa dikembangkan dalam skala luas. Ya, misalnya sedang berkembang sekarang bagaimana peternakan babi yang besar itu, lalu untuk handling of pollutant from the pig farm ini by using wetland constructed system, similar to wastewater garden, something like that. Thank you.
Selamat siang, Pak Putu.
Okay, just a moment, Prof. Adjana. This might be still Prof. Wijaya, this term. So after that will be delivered for you. Okay, just waiting. Jadi mohon maaf ditunggu dulu Pak. Jadi ini Pak Wijaya duluan. Oke, silakan Pak Prof. Jaya.
Ya.
Terima kasih Pak Putu. Terima kasih Pak Prof. Rai. Jadi bagus sekali hasil penelitian Pak Rai melalui mahasiswanya. Yang pertama Andong dan Biocat, ya. Di lapangan di padi semua ya, tidak lepas dari penggunaan pestisida. Ya, kita tahu bahwa pestisida itu berpengaruh buruk ya terhadap lingkungan, kemudian terhadap hamanya juga. Kita tahu resistensi, resistensi, hama sekunder dan sebagainya. Kemudian ternyata bahwa tanaman andong ya, yang sering kita lihat juga di sawah itu ya, kemudian yang disebut anjuang dapat menyerap terutama PB, kemudian kuprum juga CU ya, CR. Kemudian tadi saya juga berpikir seperti itu, apakah nanti bisa disarankan ya di undukan ini apa bahasa Indonesianya apa ya? Ya itu ditanam gitu. Bukan seperti Pak Prof. Rai mengatakan bahwa mungkin pola tanamnya padi, andong, palawija. Artinya bukan gitu ya. Tapi kalau itu mungkin sulit untuk jual banyak itu ya. Artinya di sekitar itu. Tapi perlu juga diketahui bahwa berapa jarak yang tadi itu, berapa perlunya harus berapa bisa apa namanya untuk menghilangkan BB dan logam berat tersebut. Mungkin perlu itu sehingga perlu di sekitar itu jangan lahan sawahnya ditanam gitu. Kemudian lahan sawah bisa saja mungkin hasilnya dibawa ke kebun yang jual tanaman itu mungkin ya. Kemudian yang kedua, biochar tadi bagus sekali juga ya, biochar tadi. Mungkin itu bisa disarankan nanti menjadi pupuk Pak Prof. Rai. Ya, sehingga bisa menyerap gitu ya. Artinya menyerap logam-logam berat. Mungkin di samping itu juga harus diperhatikan berapa dosisnya gitu ya. Kemudian untuk Prof. Nur Kartini ya, tadi Prof. Nur Kartini Abu Bakar, ini ada, saya lihat ada tree trophic level. Tadi Pak Santoso juga mengatakan kalau ke buah, mungkin nanti buah anggaplah jagung gitu, jagung ada amanya, kemudian memakan jagung itu mungkin berpengaruh buruk juga terhadap musuh alami yang kita gunakan itu, yang artinya predator, parasitoid gitu. Apakah sudah ada penelitian seperti itu? Terima kasih Pak Putu.
Okay, so before we direct to Prof. Rai, so just maybe for Prof. Kartini, so I think I understand with you catch the question. So if the fruit or sample the leaf eat by the insect, for example, this impact for the natural enemies, for example, parasitoid, predator, or another. So like this one, this question. Okay, okay. So first, the chance will be give for the Professor Rai. So please.
Thank you for the time, Pak Prof. Wijaya. Begini Prof, sesungguhnya memang benar bahwa dugaan saya kan memang pestisida itu sangat luar biasa menyebabkan terjadinya semacam polusi tanah-tanah pertanian kita. Dari penelitian S2 yang saya sampaikan tadi, ternyata ya benar dia mempolusi tanah pertanian, tetapi ternyata bagaimanapun intensifnya sampai saat ini, karena saya suruh mencari, berdiskusi dengan pihak-pihak petani yang utama sangat intensif menggunakan pestisida, lalu saya minta untuk mengambil bijinya, ternyata not detected, luar biasa. Jadi ini dugaan kita ternyata kalau pestisida tidak sampai walaupun bagaimana intensifnya ternyata tidak sampai dia dibawa ke biji, tapi kalau di daun, di batang ya. Cuman kalau di daerah hilir Sungai Badung ini, kalau pestisida kan mungkin kalau tanaman padi hanya disemprot 2-3 kali Pak ya. Coba bayangkan kalau padi di daerah hilir Sungai Badung, downstream of Badung River, every day, during 3 months, ya, the paddy rice watering by using polluted water, and then by every day also the plant absorbing the pollutant and then transported to the canopy, and then accumulated in seed, in stem, something like that. Jadi kira-kira begitu beda ceritanya Pak Man. Nah, saya memang benar, betul saran Pak Man, tentu pola tanamnya tidak padi, andong, lalu palawija, enggak. Jadi nanti saya suruh menghitung, kalau jarak tanamnya begini, saya suruh dulu ke penjual-penjual, karena andong, sansevieria, bunga matahari, dan juga itu kan digunakan untuk tanaman hias. Kalau misalnya kita katakanlah selama 1 tahun berturut-turut biar padi dulu, sehingga terakumulasi pestisidanya mengandung PB, airnya mengandung PB, baru kemudian setelah 6 kali tanam padi misalnya begitu, baru diberikan si penjual tanaman itu, silakan kamu berkembang tanam tanaman andong di sini, kemudian ambil sendiri gitu. Jadi mereka juga tidak perlu nyewa lahan, tapi mereka bisa menggunakannya, atau mungkin dengan harga murah Pak. Jadi model seperti itu. Jadi khusus setelah berapa kali. Mungkin dihitung kalau sekali berapa dia terakumulasinya tanam padi, kalau 2 kali berapa terakumulasinya. Kalau terakumulasinya tidak terlalu banyak, setelah 6-8 kali baru kita tanami dengan hyperaccumulator plant. Jadi salah satu caranya adalah seperti itu. Jadi ini adalah penelitian jangka panjang. untuk membersihkan lahan-lahan pertanian yang terakumulasi logam berat dengan menggunakan nipper akumulator plant. Tetapi menurut saya biochar ini jauh lebih menjanjikan. Oleh karena apa? Biochar ini bisa sebagai pupuk dan juga bisa sebagai mendecleaning, membersihkan lahan dengan catatan ketika dia mengekstrak logam berat dari tanah itu tidak disediakan oleh tanaman untuk diserap dibawa ke pucuk, tapi diserapnya untuk masuk ke dalam dirinya si biochar dengan tersedianya pori-pori yang banyak dalam biochar itu, sehingga tanda kutipnya adalah carilah biochar yang mempunyai jumlah pori semakin banyak. Semakin kita ketemu biochar seperti itu, maka semakin bagus dia. Karena apa? Dia akan sebagai biofertilizer and bioprotectant. Barangkali seperti itu Pak Man, terima kasih. Oke, jadi ada pertanyaan dari Pak Gong Sugiyarto, saya bacakan. Mungkin salah satu cara yang dapat dipakai adalah tanaman enceng gondok yang ditanam di hulu sehingga polutan metal bisa diserap oleh lebih awal sehingga air akan menjadi jernih. Betul. Dalam berbagai jenis tanaman di perkumulator saya sampaikan tadi ada tanaman terrestrial plant, submerged plant, and merged plant, and floating, semi-floating plant. Nah, floating plant ini salah satunya adalah eceng gondok. Kemudian kalau eceng gondok barangkali terlalu bahaya ya. Bisa kita pilih misalnya yang sifatnya menyerap nitrogen bebas. Yang kapu-kapu, kemudian asola, itu adalah juga sebagai hiperakumulator plant. Jadi ternyata di sana tidak begitu bagus berkembangnya asola. Saya suruh mengamati mahasiswa ini. Berkembangnya asola di situ, berkembangnya kapu-kapu. Ternyata mungkin karena air irigasinya yang terpolusi sehingga tidak berkembang bagus. Sehingga tinggal kita mencari asola atau kapu-kapu yang sudah terbiasa dengan air-air yang terpolusi. Kan ada di air yang terpolusi itu ada kapu-kapu, ada ini, itu kita ambil kemudian kita bawa ke situ gitu. Jadi ini kan semacam metode saja sebetulnya yang memerlukan semacam penelitian atau riset lebih jauh untuk mengatasi hal ini, karena ke depan bagaimanapun juga air irigasi akan semakin terpolusi. Karena tanah pertanian yang mendapatkan air terpolusi itu akan terserap ke tanaman. Terima kasih.
Very interesting. Maybe future research is needed for the problem solving. But now we give the question Prof. Nyoman Wijaya for the Professor Nur the insect eat the polluted plant. So how about this one? Okay, thank you.
Okay, thank you, Mr. Moderator. Okay, tadi Pak Wijaya ada mengenai dengan insect serangga kan? Saya kata tadi serangga. Apabila pollutant contohnya arsenik, dia bergantung kepada kepekatan dos yang sekiranya dos itu tinggi, mungkin kita panggil acute kan, acute toxicity, meaning that sangat tinggi kepekatannya, mungkin dengan sekali ni serangga itu sudah mati. Tetapi mungkin apabila kepekatan yang kita bicarakan biasanya dalam bioaccumulation, biasanya kepekatan yang rendah akan mungkin melalui akan berada dalam insek tersebut dalam badan serangga itu, dan kemudian serangga itu dimakan oleh serangga lebih besar dan seterusnya ikut dia punya trophic level tu. Bermaksud di sini pada apabila sampai kepada at the end higher trophic, maka kepekatan dia apabila kepekatan apabila exposure atau pendedahan kepada pencemaran itu memakan masa yang agak lama, sedikit demi sedikit, dan dia akan lama-lama dia akan jadi banyak kan. Jadi tapi kalau dengan kepekatan yang terus banyak, apabila serangga itu, sebab tu kita panggil apa, pesticide tu kan, apabila serangga itu disembur pesticide, insecticide, sembur pada serangga itu, dia akan terus mati kan. Tapi apabila mungkin serangga itu mempunyai daya tahanan yang tinggi apabila kepekatannya adalah rendah, dan dia tetapi exposure dia pendedahannya dalam suatu period ataupun tempoh yang agak lama, jadi mungkin dan mungkin serangga itu juga dia ada punya daya resistant padanya sendiri. Dan setakat ini saya memang tak ada buat tiada bidang penyelidikan saya memang lebih kepada chemical analysis, jadi memang dan dari pembacaan saya, bila kita membincangkan tentang faith of the pollutant, maksudnya apakah kesudahan bahan pencemar itu, di manakah dia akan berada. Jadi kita akan pergi kepada the high level, high tropic level bila kita melanjutkan pendidikan. Dan biasanya bila kita menggunakan dalam, bila kita nak trace daripada mana datangnya sumber ataupun punca pencemaran itu, biasanya kita boleh pakai biomarker analysis. Maksudnya kita gunakan biomarker, contohnya burung dan juga plant sebagaimana tadi, ataupun daripada isotopic analysis, cara yang bagaimana kita nak trace dari mana datangnya pencemaran itu. Jadi itu saja dari saya, dan mungkin telah menjawab soalan daripada Pak Wijaya tadi.
Okay, I
Okay.
think it's clear. Okay. Yeah, now continue for the Prof. Udayana. Okay.
Okay, thank you, Pak Putu. Okay, two speakers talk about trace element. Okay, the other side, trace element is important to rice quality, or generally in agriculture production quality. But in other hand, this trace element, it's then used when be in a abundance concentration in water, soil, or in plant. Okay. Some research show that organic matter is a good way to manage this trace element. In this seminar, I want to get some information. Maybe two speakers have another way, or a different way to manage this micronutrient. Thank you.
Yeah, I think both is can answer for this one. So first is Prof. Kartini. So
Okay, thank you. Prof. Udayana.
Udayana. Okay.
Okay. Actually, from my experience doing this type of research, I know that when we do determinations of trace elements, of course, we cannot deny the importance of nutrients from trace elements for the plant's growth. But we should know that there is optimum concentration of the nutrient should be taken by the plants, right, for the growth, for example. So meaning that if, like say, the trace elements is not enough concentration, also will be give the adverse effect to the plant's growth. And also, if, like say, the concentrations of the trace elements, for example, is higher than the optimum level that required by the plant, also will give the adverse effect. So we should know what is the optimum concentration that suitable for the plantation, for example, not only for plantation but also for other research work. For example, I have experience for my PhD work. I did a research on the speciations of bismuth in formulations of lozenge for the this is for the lozenge for the cool for lozenge for the for example what we call lozenge that we use if we have a common cold, for example, right? So when I investigate what is the optimum concentrations that I should add in zinc as to booster the immunity system, the person who eats lozenge. When I did the research work, we did measure saliva when the person suck in the lozenge, right? So we can see that if let's say you add a zinc as a trace element to booster your immune system when you suck in lozenge for cool, for example, we have influenza, for example, meaning that the concentration, the formulation, we have to know what the concentration that will give the optimum condition for the beneficial effect. If let's say it's increasing certain level, of course it will give adverse effect. So we can have a graph like it goes up with optimum condition, and then it goes back, go down, meaning that it will give the adverse effect. Meaning that every, I think not only in agriculture, in other formulations in the for example that I have done before, so meaning that they will optimum condition to for the effectiveness, even though in agriculture or even in our daily life. So I think this is my opinion to answer that question. I'm not sure whether it's answering your question, Pak Diana. I cannot hear you.
Pak Putu. Okay. I think some research show that organic matter is a good way to manage this trace element. Yeah, the dangerous of trace element. In this seminar, I want you give me some information. Maybe you have a research about the other way or different way. Not about the concentration. Yeah? The different way, yeah, because the good way is organic matter to manage micro trace element. Yeah, organic matter is a good way to manage a trace element. Okay, the research show before. Now maybe you can give me some information the different way beside organic matter.
Okay. Sorry, I can get you.
Okay, Bu Kartini, some research before show, yes, some research before show that organic matter is a good way, yeah, organic matter, yeah, is a good way to manage trace element. Yeah.
What does you mean by manage?
Yeah, manage organic matter. Yeah.
Manage organic matter.
To decrease toxicity, maybe organic matter.
Yes. Agree. I agree with you.
Yes, in this seminar, I want to maybe Dr. Kartini have some research with a different way, yeah, beside organic matter. Just that.
Okay, I understand that. Meaning that if let's say we have this organic matter, and then if let's say for example arsenic, right? Arsenic species in inorganic species is toxic, right? So when we add in certain ligand, that will change it to become the predominant species is argonobetane, for example, or arsenobetane or arsenochlorine, meaning that it become less toxic, right? So I know, but in my research work, actually I didn't do this type of experiment because my research work is based on the method development for determinations of chemical analysis in several matrices. So I didn't do it's more on how to see how the interactions metal with the protein or perhaps lipids or other when it bind with I think, and then how it will give the byproduct or metabolite that will reduce the toxicity. So I'm sorry because I didn't do the work based on that type of research, so I cannot share with you about in detail about how does it work for this.
Okay.
Mhm.
Measure about the concentration of heavy metal, but also how many micro element transported by the plant to the canopy, and so how many micro element transported to the canopy. But unfortunately, my student no have much money, so just but theoretically maybe this element is very needed by the plant, yeah. But in very small concentration. For example, in my book, I'm sorry, Prof. Adnyana, for example, tembaga just 6 milligram per kilogram, and then seng 20 milligram per kilogram. I have experience how to use compost or organic fertilizer, and the research did by my master degree in allium, bawang merah, ya. She use organic matter with the dose of 5 ton and 10 ton and 15 ton in area of Batur, pesisir Batur apa bahasa Inggris? Pesisir. Next to Batur Lake, and then she measure about the concentration of micro element, and we got that in treatment with the organic matter, this element at the soil very increasing than in control. So this means that organic matter, I think, increase and maintenance of micro element, something like that, Prof. Adnyana. I'm sorry because there is no many experience about that. And then there is a question from Mr. Gunadi. How long is needed for absorbing, for the cleaning of heavy metal from the soil if we are using biochar? Yeah. In this research of my student, the corn just input for 3 months, and then by using biochar from many kind, from 4 material, so just need 3 months to make in the soil no detecting of heavy metal, especially PB. So this means that biochar is very effective for the cleaning, for decreasing heavy metal, usually especially PB, because just 3 months in corn pot, PB not detecting again. So this means that biochar absorb all of heavy metal, apa namanya, istilah tanahnya itu kan heavy metal yang tersedia ya. Jadinya heavy metal yang tersedia itu tidak lagi terdeteksi di tanah. So I think 3 months, I think enough. But it is very different to choose what kind of biochar we have to do for the cleaning or for the greasing of biochar, something like that. Thank you.
Okay, I think it's clear answer. So now we finally move to the student. Maybe have the question because there might be important information for students. So time have this chance for you. Okay. Yeah, the student. Oh yeah. Okay. Please.
Okay. First of all, thank you for your presentation to Professor Dr. Nor Kartini Abu Bakar. I am Prila Kartika Manulang and a student from Master Agriculture. And as a student from agriculture, I rarely hear or know about the arsenic material in plant. I just know that the arsenic material is the presence of arsenic is very easy to find in our life, like the water and soil and rain, even in the biota matter. And the importance of arsenic is used for the pesticide material. And because if we use the arsenic to pesticide repeatedly, it bring the dangerous for our life. And is there any replacement of arsenic that can still be used as a pesticide making with the same function with the arsenic? And the last question is how much the acceptable level of the presence of arsenic in plant, especially in paddy? Thank you so much.
Yeah, I think clear question. So please, Prof. Nor Kartini, the time is yours.
Okay, thank you for the question. For the pesticide, the consumptions of pesticides, and then only, I'm not sure in Indonesia, but in Indonesia we have pesticide boards who restrict because you will screening, and then we have also law and regulations in order the consumptions, and then pesticide, and also we have banned certain pesticide that cannot be used. That meaning that we cannot use in Malaysia. Meaning that in order to make sure that pesticide won't contain arsenic, actually there are some, if I'm not mistaken, I'm not so sure about in details about the how much the concentration of arsenic in pesticide. And I think there are so many pesticide. I think not all pesticide have arsenic, containing arsenic. So meaning that in government level should have a rule or a regulation in order to make sure that pesticide entering the country should be do monitoring in order to make sure that the level of arsenic in pesticide to be controlled. Okay, so I think this is the best way on how to prevent about the contamination arsenic in a pesticide. And then because arsenic is it's also from the arsenic concentrations, it's also come from the natural. It's come from the nature, okay, not only from the anthropogenic activities, especially in Delta, and then in certain geographic area is may have naturally concentrations of arsenic is high in their groundwater or in also the water system. But if I'm not mistaken, for drinking water, the concentration that we allow should be less than 1 ppb, 1 ppb, 1 microgram per liter. So this is the limit, meaning that if you go screening for the concentrations for drinking water, we have to make sure that the arsenic concentration should be lower than this. If let's say the in the water body in the water body is high, then we should have go for the water filtration set. That's we do the what we call as treatment of the water system using the even biochar. For drinking water, we can use the absorbent as well. For drinking water, normally we use absorbent, activated carbon, for example, to remove this concentration. And then if you see normally the high concentration of arsenic related also to the high level of iron, because you can see that from my presentations, they also have the mineral. It's come from the iron arsenic, and if let's say the concentrations, if iron is concentrations of iron in the water system is higher, it also contributes at the same time the relationship between the iron and also the arsenic. So if let's say we notice concentrations of arsenic is higher, then we can do the clarification. We can concentrations perhaps information so if the carbons or that we can use regulating using question we can use it. So I think answering your question. Am I answering your question?
Yeah. Okay, thank you very much for the question. How about the student? Is you can understand about this one first? Yeah. Okay. Yeah. Okay. Continue for the next student because yeah, maybe some interesting one. Okay. Yeah.
Thank you for the time for me. I want to ask to Prof. Rai. My name is Karina Sari. Jadi tanaman yang dapat dijadikan sebagai hiperakumulator akankah berbeda prosesnya dalam hal fitostabilitas, fitovolatilisasi, fitoremediasi dalam mendegradasi bahan kimia antara tanaman yang hidup di darat dan di air, Prof, seperti contoh-contoh yang tadi disebutkan, dan senyawa atau hal apa yang terdapat pada tanaman hiperakumulator yang tidak dimiliki tanaman non hiperakumulator. Terima kasih.
Okay, very nice question. I think from Karina Sari. You have already. Huh? Okay, ya. Jadi perlu kita pahami bahwa semua jenis tanaman mempunyai potensi sebagai tanaman hiperakumulator. Karena apa? Tanaman itu kan sifatnya dia tidak punya, dalam buku ini saya sebut sebagai tanaman itu tidak punya sifat preferensi, tidak punya semacam pilihan untuk menyerap atau tidak menyerap, tidak seperti manusia. Ketika manusia diberikan semangka hari ini, besok seminggu, sudah bosan dia, maka dihiraukan dia, dicarilah buah yang lain. Tetapi kalau tanaman itu, apapun yang tersedia di tanah, akan terus-menerus diserap, sehingga disebut no have preference for mineral nutrition. Jadi, tidak mempunyai sifat preferensi tanaman itu terhadap nutrisi mineral, sehingga semua tanaman mempunyai potensi untuk menjadi tanaman hiperakumulator. Pertanyaannya Karina bagus sekali. Apa sifat-sifatnya sebagai tanaman hiperakumulator? Jadi ada semacam proses-proses fisiologis yang dimiliki oleh tanaman tersebut yang tidak dimiliki juga oleh tanaman yang lain. Jadi ada senyawa-senyawa tertentu yang nanti disekresikan melalui akar dan sebagainya, sehingga melalui sekresi itulah nanti polutan atau heavy metal itu diserap kemudian dipitostabilisasikah, atau kemudian diserap dipitodegradasi,kah, atau diserap kemudian dipitopolatilisation. Ya. Jadi kalau pitostabilisasi diserap tetapi tidak diangkut ke pucuk, distabilkan di akar. Jadi dia dibuat seperti kapsul, tidak aktif ya, dan terus-menerus di akar. Ada jenis tanaman seperti itu. Kemudian kalau ada jenis tanaman lain, polutan atau heavy metal itu diserap, tetapi dia ditransported to the canopy and then converted to the harmless compound. Jadi dia diubah menjadi senyawa yang tidak berbahaya. Lalu ada lagi yang diuapkan. Nah, ini sedang dipelajari oleh salah satu bimbingan saya yang meneliti tentang penggunaan biochar tadi. Ketika biochar yang tadi adalah campuran dari batang, lalu dengan tandan, lalu dicampur, ternyata di tanah itu diberikan heavy metalnya, tanaman kemana dia dibawa. Jadi ini nanti akan dicek, kembali lagi kita cari butiran-butiran biochar yang kita gunakan itu, lalu kita cek, lalu kalau memang seperti itu, apakah dia maybe be converted or be pitopolatilization. I don't know about that. So right now sedang diteliti, termasuk yang manakah dari proses-proses yang dialami oleh si tanaman jagung ini gitu. Yang mana dia prosesnya. Saya kira ini merupakan suatu hal yang sangat menarik. Jadi mumpung buku prodi ada di sini, sekaligus sebagai saran saja, buku prodi Prof. Rindang dengan berkembangnya ilmu metabolomik sekarang kan Bu Prof ya. Jadi metabolomik itu kan bagaimana produk-produk apapun dia, termasuk produk pertanian, itu tidak hanya mengejar kuantitas, kontinuitas, tetapi kualitasnya ke arah untuk kesehatan kan. Jadi dengan berkembangnya metabolomik ini, maka polutan-polutan, kemudian heavy metal dan sebagainya yang merecoki produk-produk pertanian, terutama cepat economically, ya, jadi bagian-bagian yang bersifat ekonomis itu harus kita cegah. Benar sekali Bu Asisiat Prof. Kartini tadi, bahwa memang kita harus mencegahnya lebih baik. Sehingga teman-teman atau mahasiswa di M-Agro nanti mungkin kita mulai arahkan untuk bergerak di phytotoxic ini kaitannya dengan metabolomik tadi. Pisang tidak hanya jumlah bagaimana berapa banyak pisang kita makan, tapi kalau kita makan ternyata tidak berguna untuk kesehatan, itu kaitannya adalah metabolomik. Pito yang bersifat membahayakan itu ya, dikaitkan dengan metabolomik, phytotoxic dan metabolomik. Saya kira itu merupakan bidang ilmu yang sudah luar biasa berkembang di luar, tetapi di kita khususnya, I'm sorry Prof. Nur, in Bali maybe not so develop about our aspect about metabolomic and so phytotoxic like this. Jadi ini memang belum berkembang, sedangkan mungkin di Malaysia kalau kita lihat jurnal sudah banyak sekali tentang itu, dan kalau kita lihat memang belum banyaklah di kita begitu. Jadi mungkin bisa how to create the research collaboration between us from master degree of agroecotechnology with Prof. Abu Bakar, I think. Thank you so much. Very nice presentation of Prof. Abu Bakar. Terima kasih Pak Udu.
Okay, thank you very much. Finally, I think time is up because they already very interesting, but we have time is very tired, so we should be end for this seminar. But I think I give Professor Kartini Abu Bakar, if there are something to want to conclude or something comment for you.
Okay, thank you, Mr. Moderator. Um, comment from me, actually, I think this type of activity, I think is a good activity that the student have the chances to go in depth a certain and also we as a lecturer have opportunity to exchange the research finding and also to disseminate our knowledge among us and also among the students to enhance our knowledge in the variety of discipline. So for me, basically when we talk about phase and transport of pollutant in the environment, of course there are several factors that we should consider from where it's come from, source, and then how it transport from one medium to another medium. Okay, and then what is the end of what is the ends of this movement? Either it accumulate in our body, or in plants, or in the soil. Okay, or in the sediment. So we have to understand the movement and then how from there we can prevent the pollutant from entering our food chain and also us to exposure to us as human being. I think that's all from me. Thank you.
Okay, thank you very much for this nice lecture. So yeah, I can conclude maybe some important thing is continue our collaboration. This is very important because maybe after we discuss, we open the mind like how to make the collaboration not just for the plant, maybe some question about the insect, how the impact of the chemical heavy metal for this one. I think should be have the meeting again for the next or future research, make the like roadmap research, how do step by step. This very important. This is maybe this very important conclusion for our collaboration. Okay, yeah, thank you very much. Give applause for the all participants, especially for our very nice speaker today. And now we move and return back for the master ceremony to MC. So please, time is yours.
Thank you very much to speakers and moderator and also participants for the great discussions. We will continue to next agenda. We invite the speakers and moderator to come forward to receive the certificate of appreciation to Professor Dr. Insinyur Yaman Rai MS and Ibu Tu Sudiarta PhD. Please stay in your place. And to Associate Professor Dr. Nur Kartini Abu Bakar will receive her certificate online.
Okay, thank you.
We invite the head of the Agro-Ecotechnology Master Program, Professor Dr. Rindang Duyani, to deliver certificates to the speakers and moderator. Please, Professor Rindang, come forward. Before Professor Rindang deliver certificate to the speakers and moderator in the meeting room, we proudly give certificate to Associate Professor Dr. Nur Kartini Abu Bakar for his great participation and knowledge delivery in this joint lecture. So thank you very much to Associate Professor Dr. Nur Kartini Abu Bakar.
Thank you. Thank you again.
Prof. Kartini, Prof. Kartini.
Yes.
Yes. We give this certificate for you. We appreciate for your nice presentation, for your nice sharing for our student here and for our staff also. And maybe the certificate doesn't mean that it's our collaboration is stopped here. Okay, because we need to continue this collaboration for other fields. It's not just for education, also for research and also maybe student exchange or staff exchange. Okay, are you agree for this?
Yes, I agree. Inshallah.
Okay. Thank you, Prof. Kartini. This certificate for you.
Thank
Okay.
you. Thank you very much, Dr. Rindang.
please to Professor Ryan, Bapak Putu Sudiarto, please come forward to receive the certificates. Thank you very much. Next, please, Professor Indang, Professor Rai, and Pak Putu Sudiarto, stay in your place. We're gonna have a group photo sessions together. Prof. Indang, please come forward to have group photo sessions together. The participants, please all participants to come forward and have group photo sessions together. To Associate Professor Dr. Nur Kartini Abu Bakar and participants in the WebEx room are expected to activate the video camera so we can have a virtual photo sessions together. Bapak Ibu yang di room WebEx, kami harap bisa membuka kamera videonya untuk foto bersama ya. So we have a virtual photo sessions and we're going to have the meeting room photo sessions here. Bapak Ibu, Pak peserta, mahasiswa, kami persilahkan untuk maju ke depan untuk mengisi. Bapak Ibu di ruang WebEx, kami persilahkan untuk membuka kameranya.
Ya, terima kasih saya di sebelah nih.
One, two, three. Cheese. Ladies and gentlemen, we come to the end of this joint lecture. Thank you very much for speakers and moderator and also participants for the great joint lecture and great discussions. We apologize for all of shortcomings while organizing this event. We are hoping that this collaboration between University of Malaya, Department of Chemistry, and Master Program for Agricultural Technology can be continued in the future. So we close the joint lecture by saying Pramasanti in Balinese. Om Santi 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 Om. Assalamualaikum warahmatullahi wabarakatuh. Salam sejahtera. Shalom. God bless us all. Thank you.
Waalaikumsalam.
Thank you. Santi, Santi, Santi.